We'll start in about 3 minutes. All right, it's time to start. We'll be in Chapter 7, Section 1 today, the domain of a rational expression. We'll first review what a rational number is. Okay, a rational number can be written in the form P over Q, where P and Q are integers, and Q does not equal 0. So the term rational number, a rational number is the ratio of two integers. So a ratio can be written in the form of an ordinary fraction, P over Q. Examples of rational numbers. The first two are obvious. 2/3, 2 over 3. The next one, -7/4. Terminating decimals are also rational numbers because they can be written in the form P over Q. So in particular, 0.45, that's the informal way to read that decimal number. The formal way is 45 hundredths, and you can write 45 hundredths as a fraction. And this fraction can be written in lower terms. This can be written as 9/20th. Repeating decimal numbers are also rational numbers. This one, 0.16 repeating, that is the fraction 1/6. And you can convert 1/6 into a decimal if you divide the numerator by the denominator, and you'll find that you get a repeating decimal number. Okay, a rational expression is an algebraic expression that can be written in the form capital P divided by capital Q, where capitals P and Q are polynomials, and Q does not equal 0. Okay, so the following are examples of rational expressions. They look like fractions, and you can refer to them as algebraic fractions, but they are rational expressions because the numerator and denominator are polynomials. So this first example, 5 divided by 3x minus 4, that's an example. You might wonder, well, there's not a variable in the numerator. There's just a number 5. A number 5 is a degree 0 polynomial. So even regular numbers are polynomials. The next example, x to the second plus 5x plus 6 divided by x minus 3, that's a rational expression. The next one, x minus 7 divided by x squared plus 3x minus 10. So there's really no end to how you can write examples of rational expressions. These are just 5 examples. Okay, recall that division by 0 is undefined, so the consequence of that is that fractions cannot have denominators that are equal to 0. So the same holds for rational expressions. If the variable in a rational expression is replaced by a number that makes the denominator 0, then that number is called a restricted value. So a restricted value is off limits, which means for that particular rational expression, we are not permitted to use the restricted value. So we'll look at some rational expressions and find the restricted values. Okay, so find the restricted values of the rational expressions. When finding restricted values, we only need to focus on the denominator. So this denominator is 3x minus 4. So to find the restricted value, we just set the denominator equal to 0 and solve for the variable. So we add 4 to both sides, 3x equals 4, divide both sides by 3, and we get 4/3. So 4/3 is the restricted value. That means for this rational expression, we can replace x with any number except 4/3. Sometimes we say for this rational expression, x is not permitted to be 4/3, so we say x does not equal 4/3. So just to clear up any questions that you might have, when we found the restricted value, we just said the restricted value is 4/3. But equivalently, we can say for this rational expression, x is not equal to 4/3. So we're saying that we're saying two things that are equivalent, just in a different way. Okay, the next one, x to the second plus 5x plus 6 divided by x minus 3. to find the restricted value, we don't even need to pay attention to the numerator. We want to know if there are any x values that make the denominator 0. So if x minus 3 is 0, then the restricted value is 3. So maybe I should write that out. The restricted value is 3. But equivalently, we can say that for this rational expression, x is not permitted to be 3. So we say x does not equal 3 for this one. Okay, the next example, x minus 7 divided by x squared plus 3x minus 10. Find the restricted values. So we focus on the denominator. We set the denominator equal to 0. We solve this equation, and the solutions, the real valued solutions, are restricted values. Okay, we learned how to solve equations a little bit. We can solve this by factoring. So let's see, AC method, 1 times negative 10 is negative 10. Two numbers that have a product of negative 10 and add up to positive 3 are 5 and negative 2. So remember the abbreviated AC method? So I'll point that out a few times when it's convenient to use. The abbreviated AC method, we can apply the abbreviated AC method when the coefficient of x squared is 1, like what we have here. So we found the two integers, 5 and negative 2, they have a product of negative 10 and a sum of positive 3. So when we write down the factors, since one of those numbers is positive 5, one of the factors is x plus 5. The other number is negative 2, so the other factor is x minus 2. Okay, then we set each factor equal to 0. We can see that if x plus 5 is 0, one of the restricted values is negative 5. And if x minus 2 is 0, then x equals 2. So negative 5 and positive 2 are the restricted values. And then alternatively, for this rational expression, we say x does not equal negative 5 and x does not equal positive 2. Those are the restricted values. Okay, the next example, we have x to the second minus 36 divided by x squared plus 16. So I'll give you a few seconds. Find the restricted values for this one, for x squared minus 36 divided by x squared plus 16. So if you're on YouTube and you find the restricted values, then you can go ahead and type in the answer. Oh, what did you come up with? What are the restricted values for x to the second minus 36 divided by x squared plus 16? Okay, there's a couple of suggestions online, both saying -4. Well, we can test it. If you replace x in the denominator with -4, -4 squared is 16. And 16 plus 16 is 32. So -4 is not restricted. So that, in other words, if you replace x with -4, the denominator does not become 0. Remember a sum of squares, like x squared plus 16? So we learned a couple of days ago that we cannot factor x squared plus 16 using real numbers. And so if x has to be a real number, then x squared plus 16 is never 0. So this rational expression has no restrictions. No restrictions. You can think of it this way. If you let x be a positive number, everything greater than 0, a positive number squared is positive, and a positive number plus 16 is positive. So there's no positive number you can replace x with that will make the denominator 0. If you let x be any negative number, so everything from -infinity up to 0, but excluding 0, if you square a negative number, you get a positive number, and a positive number plus 16 is positive. So there's no negative number that makes the denominator 0. And then the final number to test is when x is 0 itself. 0 to the second plus 16 equals 16. So 0 doesn't make the denominator 0. So we say there are no restrictions. Okay, the next example, x to the third plus 64 divided by x squared minus 49. So find the restrictions of that. We're focusing on the denominator, x squared minus 49. Are there any real numbers that you can replace x with that make x squared minus 49 equal to 0? Yeah, there are two numbers. One is positive 7 and the other is negative 7. So we do have two restrictions. We can say, well, to find the restricted values, I'll set the denominator x squared minus 49 equal to 0. This is a difference of squares because 49 is 7 squared. We can factor a difference of squares using real numbers. One factor is x minus 7. The other factor is x plus 7. And then if x minus 7 times x plus 7 is 0, the two solutions are x equals 7 and x equals negative 7. So this has two restricted values, positive 7 and negative 7. So another way to indicate what the restricted values are, we say x. We cannot allow x to be 7 because that makes the denominator 0. And we cannot allow x to be negative 7 because that also makes the denominator 0. Okay, so you can see there's a difference. Maybe I shouldn't have used that word, but a sum of squares is not the same as a difference of squares. We can factor a difference of squares using real numbers, but a sum of squares like x squared plus 16, we cannot factor that using real numbers. Okay, the next rational expression, 10w minus 5 divided by 2w to the second plus 11w plus 5. Let's find the restricted values of that. So if all we are doing is finding the restricted values, we only need to focus on the denominator. So to find the restricted values, we set the denominator 2w to the second plus 11w plus 5. Set it equal to 0. The solutions, the real valued solutions, are the restricted values. We can use the AC method to factor this. Since the coefficient of the w squared is 2, we cannot use the abbreviated AC method. We have to use the full AC method. So multiply 2 times 5, and we get 10. Find two integers that also have a product of 10 and a sum of positive 11. So 1 and 10. 1 times 10 is 10, and 1 plus 10 is 11. So we can factor this with real numbers. So we replace plus 11w with plus 1w plus 10w. And then we factor by grouping. Out of the first two terms, 2w to the second plus 1w, we can factor out w. And the binomial is 2w plus 1. Bring down the middle operator of addition. And out of the third and fourth terms, we can factor 5 out. And the binomial is 2w plus 1. And then the complete factorization, 2w plus 1 times w plus 5. Okay, so to find the restricted values, set each of those factors equal to 0. When we set 2w plus 1 equal to 0, to solve for w, we subtract 1 and divide by 2. So one of the restricted values, we can say w cannot be negative 1 half. The other factor, w plus 5, set that equal to 0. So the other restricted value is w is not permitted to be negative 5. Okay, a couple of more. So this one on the left, negative 11y plus 1 divided by 30y to the second plus 25y minus 5. To find the restricted values, we just focus on the denominator. The denominator is 30y to the second plus 25y minus 5. We want to find the restricted values, so we set it equal to 0. And the solutions to this equation are the restricted values. The greatest common factor of all three terms is 5. And so we can divide every term on both sides by 5 just to get rid of the excess clutter. Divide both sides by 5. Divide every term on both sides of the equation by 5. We'll get 6y to the second plus 5y minus 1 equals 0 divided by 5 is just 0. And then we can solve this by factoring. So the AC method, 6 times negative 1 equals negative 6. Two integers that have a product of negative 6 and a sum of 5 are these two integers that we already used, 6 and negative 1. If you add those, 6 plus negative 1, you get positive 5. So we can factor this. So I'm going to rewrite it as 6y to the second minus 1y plus 6y minus 1. Out of the first two terms, 6y to the second minus y, we can factor y out. And the binomial is 6y minus 1. The middle operator of addition, I bring that down. And what can I factor out of 6y minus 1? I can factor 1 out. So this is one of those areas that common mistakes are made. When we're factoring by grouping, if the greatest common factor is 1, then make sure that you write plus 1 times, in parentheses, 6y minus 1. If you forget to write the plus 1, you might forget the plus 1 in the factorization, which gives you an incorrect answer. Okay, then the last step, the binomial 6y minus 1 times the binomial y plus 1, and the product is 0. Okay, so to find the restricted values, set each of those factors equal to 0. If 6y minus 1 is 0, add 1 and divide by 6, we get y equals 1/6. And the other factor, y plus 1, set that equal to 0, and y equals negative 1. So the restricted values are y equals 1/6 and y equals negative 1. Equivalently, we can say for this rational expression, y does not equal 1/6 and y does not equal negative 1, because those numbers make the denominator 0. but division by 0 is undefined. Okay, the next one, we have another rational expression. Find the restricted values. So we just focus on the denominator. The denominator 84n to the second plus 76n plus 16. To find the restricted values, we set it equal to 0 and then try to solve that equation. The greatest common factor of the three terms is 4. So in an equation, it's perfectly legal to divide every term on both sides of the equation by the same non-zero number. So if we divide every term on both sides by 4, we'll get 21n to the second plus 19n plus 4, and 0 divided by 4 is 0. Okay, now we want to factor this, so we'll try the AC method. 21 times 4 is 84. And we want to see if we can find two integers that have a product of 84 and add up to 19. So let's see, 1 times 84. I have limited space, but I'll try the exhaustive method or the systematic method. 1 times 84, 2 times 42, 3 times 28, 4 times 21, 5 is not a factor, 6 times 14, those add up to 20, but that's not quite 19, and then 7 times 12. So 7 and 12 add up to 19, so we can factor it. So we'll transform this to 21n to the second, all right, plus 7n plus 12n plus 4 equals 0. And then factor by grouping. Out of the first two terms, 21n to the second plus 7n, we can factor 7n out, and we're left with 3n plus 1. And then bring down the middle operator of addition. Out of the third and fourth terms, 12n plus 4, we can factor 4 out, and we get 3n plus 1. And the two factors are 3n plus 1 times 7n plus 4. So the restricted values, if 3n plus 1 is 0, we subtract 1 and divide by 3. So n equals negative 1/3 is one of the restricted values. The other factor, 7n plus 4, subtract 4 and divide by 7. The other restricted value is negative 4/7. Okay, so the thing to remember when finding restricted values of a rational expression, we only need to focus on the denominator and find the real numbers that make the denominator 0. If there are any, so there will be cases where there are no restrictions, like this one. Okay, we'll spend a few minutes Simplifying rational expressions. So simplifying rational expressions is like simplifying ordinary fractions by writing them in lowest terms. So we'll look at some ordinary fractions and write them in lowest terms, and then apply the same concept to rational expressions. So 14 divided by 21, if we write the numerator in factored form using prime numbers, 14 is 2 times 7, and in the denominator 21 is 3 times 7, and 7 divided by 7 equals 1. So this fraction simplified is the fraction 2/3, because 7 divided by 7 is 1. For this one, negative 25/15, well, we can think of that as negative 5 times 5. And then in the denominator, 15 is 3 times 5. 5 divided by 5 equals 1. So this simplifies to negative 5/3. Okay, the next one, 66 over 110. Well, 66 is 6 times 11. (110) is 10 times 11. And 11 divided by 11 equals 1. So we can at least write 6 divided by 10. 6 divided by 10 can be simplified further. So we want to do that. So think of 6 over 10 as 2 times 3, and 10 as 2 times 5. 2 divided by 2 cancels, so we're left with 3/5. Hey, a more efficient way to have done that would have been to note that 66 is 3 times 22, and 110 is 5 times 22. And then 22 divided by 22 cancels. But either way, if you keep going, you'll get to the simplified result, 3/5. The fraction 5/2, this is already as simplified as it can be. So in this class, we don't write mixed numbers, we just write improper fractions. So this one is already simplified. Already simplified as it can be. Okay, we'll apply the same concept to rational expressions. So here we have x squared minus x minus 2 divided by x squared minus 3x plus 2. So on these, on the rational expressions, we'll simplify them, but we'll also note what the restricted values are in the original expressions, because those have to be maintained throughout, even after canceling common factors. So we can factor the numerator. The numerator turns out to be x minus 2 times x plus 1. The denominator turns out to be x minus 2 times x minus 1 when you factor the numerator and the denominator. So we note the restricted values. Those are the numbers that make the denominator 0. So the denominator, the factors in the denominator are x minus 2 and x minus 1. So the restricted values are 2 and 1. But then to write this in lowest terms, note that the factor x minus 2 divided by x minus 2 cancels. So the simplified expression is x plus 1 divided by x minus 1. Okay, but I want to emphasize a little bit that where this started out matters, even though this doesn't look like it has a restricted value of 2. Since we began with this rational expression, we have to include 2 as a restricted value even after we simplify. So it's obvious that 1 is still restricted, but we also list 2 as a restricted value. Okay, in the next example, x squared minus 3x minus 10 divided by x squared plus x minus 2. The numerator factors to x minus 5 times x plus 2. And the denominator factors to x minus 1 and x plus 2. And you can verify by multiplying that we have the right factorization. So note what the restricted values are. The restricted values, one restricted value, x minus 1 is 0 when x is 1, and x plus 2 is 0 when x is negative 2. So 1 and negative 2 are restricted values. And then when we write this in lowest terms, or when we simplify it, we divide x plus 2 by itself to get 1. And so the simplified expression is x minus 5 divided by x minus 1. Hey, this one, x minus y divided by y minus x. Note that this is x minus y divided by the negative of x minus y. The negative of x minus y is the same as y minus x. Okay, restricted values. Well, anytime x equals y, we have a restricted value. So this is an infinite number of restricted values. But it makes sense if you pick x to be 5 and y to be 5, then you're dividing by 0. Because 5 minus 5 is 0. So anytime x is y, we get a restricted value. But this simplifies to negative 1. This is like 1 times x minus y divided by negative 1 times x minus y. Cancel the common factors. 1 divided by negative 1 is negative 1. But we still have restricted values. Okay, the next example. So this one looks a little more involved. In the numerator, 3a to the second minus 12ab plus 12b to the second. And then the denominator, 6a to the second minus 24b to the second. So in the numerator, factor out the greatest common factor. The greatest common factor is 3. And then we have a to the second minus 4ab plus 4b to the second. And in the denominator, 6a to the second minus 24b to the second. The greatest common factor is 6, so we factor that out. And in parentheses, we have a to the second minus 4b to the second. The numerator factors pretty nicely, a to the second minus 4ab plus 4b to the second. That is a perfect square trinomial. So one of the factors is a minus 2b. The other factor is identical, a minus 2b. You can verify by multiplying. And in the denominator, we have a difference of squares, a to the second minus 4b to the second. So one factor is a minus 2b. The other factor is a plus 2b. Okay, so 3 divided by 6 is going to simplify to 1 over 2. And then one factor of a minus 2b from the numerator cancels with the a minus 2b from the denominator. So these cancel each other out, and 3 divided by 6 is 1 over 2. So this simplifies to a minus 2b over 2 times a plus 2b. The restricted values so one of the factors in the denominator was a minus 2b. So anytime a is equal to 2 times b, that's restricted. The other factor, a plus 2b, anytime a is equal to negative 2b, then that's restricted. So for example, if you picked b to be 1 and a to be 2, then that would amount to a restricted value because that would cause division by 0. Okay, the next one, 2x to the second minus 12xy plus 18y to the second divided by 3x squared minus 27y squared. We can factor 2 out of every term in the numerator, so we get 2 times x squared minus 6xy plus 9y to the second. And in the denominator, we can factor 3 out, so we get 3 times x squared minus 9y to the second. 2/3 cannot be simplified, but in the numerator, we have a perfect square trinomial. The factors of x squared minus 6xy plus 9y squared is, the two factors are x minus 3y and x minus 3y. And in the denominator, we have 3 times a difference of squares. So this one is x minus 3y times x plus 3y. So one factor of x minus 3y from the numerator cancels with the x minus 3y from the denominator. And nothing else can be simplified, so we can just write 2 times x minus 3y in the numerator divided by 3 times x plus 3y in the denominator. The restricted values are anytime x is 3y and x is equal to negative 3y, those will determine the restricted values. Okay, so there's a few minutes left, but let's go ahead and stop for today. Remember, there's the second test next Thursday, and on Tuesday and Wednesday of next week, we will review for test 2. I did send the test 2 review sheet, so look for that in your email. But that's all for today.